Hello, sir. Shall I start?
Yeah, please start. Madam, I'm stop sharing the screen. We can now take over. Okay.
Okay, thank you. Okay. A warm good morning, good afternoon to one and all. I'm Dr. M.J. Jaisri, Student Activities Chair of IEEE EMBS Kerala Chapter. So I'm very glad to inform you all that the IEEE EMBS Kerala Chapter had started the distinguished lecture series this year. So first lecture was on 5th March 2021. This is our second talk, and the topic of today's presentation is Biology in Space, Challenges and Opportunities for Engineers. So our distinguished speaker is from Indian Institute of Space Science and Technology. So let me enter into my duty of welcoming our speaker of the day. In spite of the busy schedule, she has wholeheartedly accepted our invitation and honored us today with her gracious presence to deliver the lecture. So we are indeed delighted to have such an eminent professor as our speaker. So on behalf of the IEEE EMBS Kerala chapter and on my own behalf, I extend to you, ma'am, a hearty welcome. Thank you, Dr. Jaisri. And we deeply appreciate the support of Dr. Manoj B.S., the chairman, and Mr. Baiju NB, the secretary of IEEE EMBS Kerala chapter, for their valuable inputs, advice, and guidance for this distinguished talk series. So I extend a hearty welcome to both of you, sir. So last but not the least, I'm pleased and privileged to offer a cordial welcome to all the participants, including the members from IIST, then professional members, graduate members, and student members who are here for attending this webinar. Thank you. And I hereby invite Manoj sir to introduce the speaker.
Good afternoon. It's a pleasure and honor for me to introduce our speaker, Dr. K.G. Srijalakshmi, who is an associate professor at the Indian Institute of Space Science and Technology, Trivandrum, where I also work as a professor. She received her PhD in chemistry from University of Kerala. She leads a very large research group focusing on organic molecules and functional materials. She joined IIST as a founding faculty member, an elite group of very small number of faculty members who started the institute in Trivandrum. She joined first as a Department of Applied Sciences faculty in 2007, and after a short stint of postdoctoral research at BMT wing of Sri Chitradirunal Institute of Medical Sciences at Trivandrum, she now works at the Department of Chemistry at IIST. Our main areas of research include combinatorial chemistry for material development, drug discovery, gravitational biology, and space life sciences. Currently, she is leading a research team that is developing biology payload for the first developmental flight of Indian human space program. Additionally, she coordinates the activities of Technology Incubation Center at IIST, intellectual property rights evaluation committees, and leading teams for various patent-related evaluation activities at IIST. She led several efforts in international collaborations, including the most recent Memorandum of Understanding, which has been signed between IIST and TU Delft, the leading university in the Netherlands. She has more than 25 international publications, 4 patents, and more than 60 invited lectures to her credit. She's a member of various professional bodies, including IEEE. Really glad to introduce her. She's my faculty colleague and active researcher at IIST. We are very glad to have you here in this IEEE EMBS Society Distinguished Lecture Series. Thank you for accepting our invitation, madam. Please.
So, warm good afternoon, and I thank Professor Manoj wholeheartedly for this kind invitation. Otherwise, I would not be here in this platform. And before starting the presentation, I would also thank Dr. Jaisri for those welcome remarks she made. So for all the delegates over there, please give me a few seconds time. I will start sharing my screen, and then we'll go about the presentation. I hope my screen is visible now.
Yeah, yes, madam. Yes, visible.
Trying to put it in the presentation mode. Yeah, now it is in the presentation mode, I suppose. Yeah. So yeah. So here we go. So a very warm good afternoon to each one of the participants in this forum now. And today, this afternoon session, I'll be talking to you on a very unique subject, in fact, because we believed once upon a time that biology and engineering, they stand apart. So now it's time for us to believe and appreciate that the biology in space is something that we are venturing into, especially the Indian space program is venturing into, and that gives immense a number of challenges along with the opportunities, immense number of opportunities for the engineers of the country as well as abroad as well as. So myself, Srija Lakshmi, I represent Indian Institute of Space Science and Technology, the one and only institute, academic institute supported by Department of Space, Government of India, and we offer undergraduate, postgraduate, doctoral and postdoctoral programs in various areas of space science and technology. So in this forum, this lecture series 2, I'll be talking to you about biology in space. In that, these are what you can expect from this lecture. Because I just wanted to make it a comprehensive one, because the area what I wanted to talk is immense. I mean, it's vast topic, so we need to put some boundaries somewhere. So I thought of giving you at a glance what we are going to expect, or what you are going to expect. You can expect from this talk. So basically, I will start about talking about space biosciences by giving a very brief introduction. This may be very much familiar to all of you. And what brings or what makes the space laboratories unique as when we compare them with the Earth-based laboratories. So when it comes to space biosciences or space biology, we have the ultimate goal of supporting and helping the life in space. So that brings us to some of the important parameters like the grand challenges which are associated with maintaining life in space. So that we will talk about space synthetic biology and the grand challenges which are outlined as of now. Then I will talk about something what we call as microgravity platforms, where we are facilitated or we are helped in performing those space analog experiments on Earth-based laboratories. And I'll also talk about the prospects as well as opportunities for research in these multidisciplinary areas, as well as before winding up, we have taken small baby steps in the area of space biology in IIST. So what are the initiatives that we have already taken, as well as the future directions, what we are focusing and what you can focus, that also I'll be talking to you about. So this is a disclaimer. The target audience for this particular lecture I have prepared here are not only engineers, not only space biologists or space scientists, every passionate learner and the futuristic researcher is a potential target audience for this particular lecture. With that, let us move on to the core of the topic. So we will have a very short intro on space biosciences as well as space life sciences. It may be very much familiar to you. When we are talking about space biology or space biosciences, we are actually talking about the biological as well as the biomedical processes when we take live specimens as experimental subjects and perform those experiments on the space laboratories. Okay, so when I talk about live specimens, definitely there can be question, who is considered to be live? So as far as the organizational chart is made for live specimens in terms of biological studies, we consider 6 parameters, and if these subjects are meeting these parameters, we call them as live subjects. So these parameters I have listed over here. One is the movement. Okay, so if the body is able to move from one place to another, or maybe in some form, because the plants are not moving from one place to another, but they are moving with respect to their shoot length or root length or whatever. So those type of movements. Then organization. In our body, we have organizations, tissues are organized into organs, like that. Hierarchical organizations are actually available so that to perform certain functional roles. We call that as organization. Then homeostasis, it refers to some sort of a balancing. Okay, some parameters, for example, temperature within the body is maintained to certain temperature. So it is actually a balancing act. So homeostasis is something which we call it. Then energy, the utilization of energy as well as the preparation or the making of energy. These two things are also attributes of live specimens. Then becomes reproduction is there, because if the bodies or if the specimen is able to reproduce and give birth to its offspring, that is again considered as a live specimen. Then of course everything combined together we call the growth aspects. So these 6 aspects, if a subject of if a body is meeting, then we can call it as a live specimen. Okay. So we are now considered or when concerned about the space as the laboratory. Till now we are much familiar. For example, in India we are much familiar with earth-based laboratories where we perform day in and day out so many research activities. But when it comes to space biology or space biosciences or space life sciences, several terminologies are available. When we consider this particular aspect, then space becomes the laboratory. So when space becomes the laboratory, there are very unique aspects which are associated with the space laboratory. The first and the foremost that we are all familiar with is that such laboratories are deprived of the so-called directional stimulus that we on Earth are deriving from the so-called the 1G force or the gravitational force. Okay. So as long as the life evolved maybe 4.2 billion years ago or something, we in Earth never ever have faced a deficit of this gravity. Okay. So imagine the biology or the life that evolved in this particular 1G condition. We are trying to take it to somewhere else where this particular directional stimulus is actually lacking. The magnitude wise as well as the quality wise, that there are many variations which are manifesting between different celestial bodies when we consider this microgravity force or the gravitational force. Apart from that, the loss of sedimentation. When we take a sample to space, there is no sedimentation force acting upon there. So the loss of sedimentation is another attribute which are which are with the sample which we are taking, the biological sample which we are taking to space is going to experience. Then of course the convection forces, especially the density driven convections, are actually not at all prevalent in space. So there are different physical attributes or physical manifestations of this aspect as well, not only biology. And moreover, the mechanical diffusion. This is another phenomenon which is actually prevented in space. Why I'm listing out these many factors is because whenever the engineers are trying to help the biologists in conducting some experiments, these are all the features which are making the space laboratories different from Earth-based laboratories. So we should be understanding the fundamental distinction between these two laboratories. And apart from that, when we are talking about the convections on Earth, there is something which we ignore or which is not that important, which we call as Marangoni convections. So you may be familiar with the Marangoni convections. I'm pretty sure engineers are familiar with this term. So when it comes to microgravity conditions, surprisingly, these Marangoni convections are dominating. So this also brings in certain, for example, a bubble to rise from the liquid surface and evolve into a gas and all. It's actually limited. Okay, so the different physical phenomena are actually different when it comes to the space-based laboratory. So many more aspects are also there, but I just listed a few of them here. So the later part, definitely when you get involved in some biology related projects, definitely you should be knowing them. Maybe many textbooks are available in this context. And when I progress with the lecture, so many references will be listed in my slides. Student community, please make sure that you are noting it down or you are recording it somewhere so that you can actually go into the details of the research that is explained over there. Okay, so we come back to the biology lab, and when we consider this biology conducted in space, in fact, there is one laboratory which is actually orbiting at an altitude of 408 kilometers. You people will be knowing it, at approximately 7.77 kilometers per second velocity. So it is none other than the International Space Station. So over the past 20, 21 years, the particular space laboratory has been continuously dominated by people. Never ever in a single day was there without any important experiments being conducted there. So over the years, when we are having even the first human mission, it happened some 60 years back, maybe 2-3 months back only, the Yuri Gagarin's historic flight. 1961 flight was having its 60th anniversary celebrated. So the point that I wanted to make here is that the space biology or the space biosciences has been there for quite a long time. Okay, why we are interested now is that we are having something unique situation now in our country. I'm talking about India, our country. So we have a unique condition. So that calls for more and more and more people getting informed about these advancements as well as getting involved in the research. So that is the basic reason when Professor Manoj was asking me whether you can give a lecture, I was thinking just to give about an overview of what all things are possible and what all things we already started. The wheel started running already. It started spinning already. So how fast we need to propel it, that also is our concern. Okay. So as I mentioned, the space biology is a very, it's not very old, it's pretty old subject now, where the investigations have been carried out using human body, then numerous plants, animals, of course. So these people know animals, in fact, animals other than human beings. They were actually the experimental subjects who used to be sent to space in the beginning. You people all will be knowing the Leica and the Mangi. So many people actually traveled. So I will come to a small, in a short span, I'll come to some history of space flights also. Then the development of habitats, because now from small or the LEO orbits, we are trying to move into so-called deep space missions. So the habitat development also is a critical area currently being explored in the context of space biosciences. Other than that, definitely food is one important aspect, because when we are traveling to space, we are limited by the resources that we are currently taking with us. For example, even including oxygen, we are having oxygen, then water, then food, everything we take, and we are actually having limitations with respect to those so-called resources available. Okay, so when with respect to this space biology that I have mentioned over here, because in the early years, it actually started with the assessment of the ability of these organisms, the life specimens, to survive spaceflight. So surviving the spaceflight included the launch as well as the re-entry shocks as well. Okay, it's not only the time in which they can survive in space, the whole throughout the spaceflight and returning back, whether they are able to survive. So that was one among the important assessment that early years of space biosciences research was considering. And after a long number of trials and explorations, currently we understand clearly that not only animals, humans, as well as plants, all can actually withstand the exposure to microgravity. So the microgravity is not a big deal. Okay, so we are having some countermeasures now. We are having some sort of exercise machines, this and that, so that we are able to counteract to such problems which are arising from the exposure to microgravity conditions. But with respect to cosmic radiation, the cocktail of radiations that the space travelers are experiencing, it's not only from this galactic cosmic radiations, some solar particle events. In fact, it's a cocktail of radiation. So simulating those all radiations on Earth, even in the right proportions, it has not been achieved even today, as far as in my knowledge. So this is one among important parameters that we have to address when we are taking biology to space. Okay. Along with that, the rigors of launch and re-entry. So these things, to what extent the subjects can, the animal, plant subjects can actually withstand. This is also an important concern when it comes to our launches, human launches. Then from this basic understanding, now the focus has been shifted slightly more into understanding the deeper aspects of the biology. For example, the biological changes that are occurring at cellular as well as molecular levels. Okay, so during and after space flight. So before space flight, during and after. So what are the changes that are occurring? And if there are changes are actually detrimental, then how can we avoid such, such unwanted changes. So that the main aim, whenever we are focusing on human space missions, the main aim is that we are sending a human being every second, every microsecond of that particular person has to be utilized productively in space. Okay, so for that also we need to have assistance from Earth. So one important point that I'm talking about is that even when we are talking about space biology or space life sciences, the most important component coming there are actually the optimization of the experiments which we have to do in Earth-based laboratories. So please don't assume that when we are not getting direct opportunity to enter into space experiments, we are not there. You are very much there. Okay. What we want is we have to understand what is being done or what is to be done. Then the same experiment on Earth-based analogs we can perform, we can perfect, we can optimize, and we can make them space ready. Okay, so that is one important point that I wanted to share with all the youngsters sitting over there. Okay, so when we are talking about space as a laboratory, I mentioned some of the unique attributes of space laboratory. So where do you consider, or where do we consider the space to start? Okay. So with respect to this particular lecture, we cannot assume that the space is just starting at an arbitrary point, just some distance above the surface of the Earth. So with respect to this particular lecture, what I'm talking to you about is about physiological space. Okay, so where the life, the human body or the animal body has to survive, the life specimen has to survive. So in that context, we can actually define the physiological space as a distance. For example, when it comes to say 12.5 kilometer or so, there will not be any oxygen, or we need 100% oxygen support. We need to carry a cylinder. Okay, it is altitude slightly above 12 kilometers. But when it comes to altitude above 18 kilometers, or precisely 18.26 kilometers, or maybe 19 kilometers, we can call it roughly, we have a situation where you cannot survive without a spacesuit. Okay, so when I talk about spacesuit, you know how complex the system is. And the spacesuit is one among those systems which require huge amount of engineering intervention. Okay, starting from fluid dynamics, starting from the sensor networking, so many attributes are there. If you material development is another aspect, so it's a highly interdisciplinary area. So the point is here that physiological space, we are talking about the so-called physiological space, and it is actually above 18.28 kilometers in altitude, where the life cannot be sustained without artificial support. So along with oxygen, you require a pressurized cabin or a spacesuit, whatever you call it, in order to sustain your life. Okay. So this is very important. So in fact, the true space is actually something, beyond what you call as the Van Allen belt and all. We will not talk about those aspects. But when we are considering the space biosciences, especially with respect to the ISS missions or with respect to India's forthcoming mission, we are talking about the LEO, the low Earth orbit. Okay, so our mission is to take the Gaganyaan to 403 kilometer altitude, whereas our ISS is actually orbiting at an altitude of 408 kilometer above the Earth's surface. Okay, so in general, if I put the space life sciences research goals, the objectives, I have listed two of them. Okay, so the first and foremost definitely is to study the exposure or the effect of exposure of the microgravity on biological systems. So why do we want to understand the effect of the exposure of microgravity on biological systems? Is because we are pretty much sure that we are going to send humans. Okay, and now the space flight has become commercial also, isn't it? The one private company, okay, that Virgin company, that they have which Virgin Galactic, they have already sent a 6-member crew and they have come back safely. So space tourism already started. Okay, so there is no point in thinking that space biology is, it's a separate domain. It again comes with tourism also, it is going to get associated. So the second objective of this space life sciences research is actually to use this microgravity platform, the unique microgravity environment, to broaden the scientific knowledge about the influence of gravity on living systems. Not only about the influence of gravity on living systems, how good this microgravity is going to when it comes to research in some material science. For example, in our group, we are also trying something with crystallization experiments, because crystallization in space is believed to be much superior to the quality of crystals that we grow on Earth, especially because the sedimentation is not there. So the nucleation thing and all, no, they happen very in unique fashions. Okay, so the microgravity environment is one thing that we want to explore to broaden the scientific knowledge. Okay, so having said all these things, now comes what is happening. So even if in India we are talking about space life sciences as a new domain, this already we are having a so-called the International Space Life Sciences Working Group. It's a global community. You can see the agencies which are getting collaborated in that. So we are having ASI, we are having CNES, we are having CSA, DLR, ESA, JAXA, and NASA. So when people are talking to each other today at the International Space Station, Expedition 65, the crew members here, the 7-member crew is doing all experiments, whatever is assigned to them. So they are performing all the experiments in that particular orbiting platform now. And the research in orbit, this is something that is as a collective, summary of something which already happened in the ISS. You can see the different space agencies and the different segments of research that they have carried out. So as of now, maybe around 3,200 plus experiments have been conducted successfully in this orbiting laboratory. So more details are available in this particular link. So some of the selected experiments in the past mission, 63rd mission, it is talking much about, I have just handpicked a few of them, which is important with respect to this particular talk. So the cardiac and vessel structure functioning, so currently the water recovery system, and then dexterous manipulation in microgravity. This is something new, the manipulation of our dexterous components or features. It's very difficult and important aspect when it comes to. So all these things, most of them, and lot many I have not listed. A complete list is available in this particular link. You please go ahead. And in case, I hope many of the students here, they are familiar with the ISS tracking app and all. No, we are even able to know when the ISS is going to cross our house, our premise, our building. We can actually see it. Okay, so the ISS app is available. You can download if you have not done already. You can see when it is spot the station. The NASA call it a spot the station app. Okay, so for those who are interested in following what is happening at ISS, this is something, the annual International Space Station Research and Development is this. It's one group is there. You can actually register there. They will send you about the updates which are happening. So upcoming event is actually open for registration if you are interested. It's a very good platform where the real astronauts, people who are really into the field of research in not only in space biology, almost all the areas which are being conducted on space, this platform is being discussed. So you are having this is an information for you. The event is from 3rd to 5th. Already the program they have announced. So you register and you will start getting this newsletter, important updates which are happening on ISS. So this is for the information of the upcoming researchers. Okay, so this is what I just told you earlier, the history of space science experiments. You see, not only with this 61 human space flight or the Leica's travel in 1951, even before that, there are documented studies on space flights carrying biological specimens. For example, 1946 to 47, from New Mexico, that Alamogordo, there's a launch station from where the balloon flights were actually sent in. And you see the altitudes, 170. So crossing 100 kilometers was supposed to, or is supposed to be the space flight even now. So the attempt was to study the effect of cosmic radiation in the upper Earth atmosphere using fungal spores and fruit flies. So you can see here, fruit flies I have actually highlighted in 2 places. There's a significance for that. So in fact, with respect to history of space biology, fruit flies are one among the first space traveler. Okay, so just bear it in mind. I'll talk to that about slightly later. Then the hierarchy of events with all the biological samples, this is not ending here. It's a huge article, and the whole thing you can actually download it from this particular link, whatever I have mentioned. We will move faster now. Yeah. So what is that thing? Why our country is now starting to talk about space biology, or we are starting to learn about space biology now? This is all due to this big announcement which happened 2.5 years back, where in fact 3 years back. Now it is almost 3 years after this announcement. So the Indian government has announced the India's first human space mission, what we have named as Gaganyaan. Okay, so this was the wordings then spoken by Indian Prime Minister when he announced this particular huge event from different parts of the Red Fort on this Independence Day of 2018. So Gaganyaan is actually India's first human space mission. So by Gaganyaan, we are actually anticipating this our GSLV Mark III to lift off from Sriharikota and to reach the LEO orbit, 403 kilometer we are expecting to reach. Then we will be having our module in space for 5 to 7 days, and there will be a splashdown which is happening at the Arabian Sea, and crew module recovery is expected to be happening in 15 to 20 minutes. Okay, so here most important thing is that along with this module we are having 3-member crew, all Indians, okay, who will be traveling to LEO first time using Indian space vehicle, okay, and we are expecting or we are planning for the safe return of these Gaganauts or Vyomnauts, whatever terminology we are using later. So we have to take them back safely after the mission duration up to 7 days. Okay, so for this particular event to happen flawlessly, ISRO has enhanced its capabilities. So ISRO's capabilities, as you all know, was with respect to space transportation systems and satellite systems as well as space application systems. So with the announcement of this particular landmark announcement which was made, the ISRO has actually expanded its domains into new human-centric domains. So as an organization like ISRO, if it is expanding its activity, definitely it comes with a lot of opportunities. Every Indian academia, every Indian industry will be having unique opportunities to contribute to this particular program. Okay, so currently we are looking forward for the development of human rated platforms. So the more we perfect them, the more we are going to be safer. Okay, and apart from that, we need to have our own unique astronaut training facilities. Okay, so a unique center is being set up in the outskirts of Bangalore. It is getting ready, and our astronauts, 4 of them, have completed their training. Who have been selected for the Gaganyaan program. They completed their training, and they are now undergoing their program at our own facilities. Then apart from that, a large number of human life support technologies, these are also that we want to develop now. Okay, so what is more important is that before these crew members are really traveling, we will be having 2 developmental flights, what we call as. Okay, so in developmental flights, what we expect is to have every other component than the humans being traveling in this particular module. Okay, so these are experimental flights. Why we want to conduct them? Just because to the assessment of the performance of the flights. Okay, so end on end we have to assess the performance, and we have to make sure that things are working pretty clearly. Okay, so what is more interesting for us is that the host of opportunities that is envisaging, that is ensuing this particular announcement is something which is really, for me, it was a thrilling experience actually. Okay, because I have been looking for this opportunity for quite a long time. Okay, so even from my periods of my PhD, my days of my PhD, I was eagerly looking for the announcement of Indian human space programs. So not only sciences, technology development also become a critical step in the successful completion of these missions. Okay, so we are now talking about the space biosciences. So here, why I'm talking about this is because, as we mentioned, our country is just starting to. Okay, so I was fortunate enough to have been a member in the space biology, or in fact the microgravity vision document preparation for ISRO, for the country itself. So we were having a lot of deliberations with people from academia across the country, very famous scientists. Okay, so we were trying to find out how we can lead the space biology research in India to the certain height, because currently we know we are lagging well behind, right? Because some 20-25 years we are lagging behind. But our aim should be, it is not to become a pioneer in the field and all, we cannot actually claim, because space biology happened long back, isn't it? So what we expect is to become an important link in the space biology continuum. So the space biology is actually it's continuing as a, it's propagating its own knowledge expansion and all. So how India can become a very important link in this biology continuum. Space biology continuum is going to be our aim. Okay, so the different steps in the initial years, we have to have different hierarchical events which are happening, planned events which should happen, among which an identification of ground-based analogs of this spaceflight experiment. That is very, very critical. I have already mentioned it. So that we have to build the so-called microgravity science platforms. Okay, all the time we cannot look for flight opportunities, but at the same time, when you perfect some experiment and keep it ready, at the earliest flight opportunity, you can actually send it for flight. Okay, so this is something which all academic institutes or research institutes can look eagerly forward, because there will be announcement of opportunity calls, AO calls we call them. So you keep watching the ISRO's website, you will be finding opportunities. So the right opportunity you can grab and you can start your own research. Okay? So research teams, setting up of research teams, and space biology proposals will be solicited in the near future from ISRO. So these all aspects will go in the first phase. Okay, and in the second phase, we have to introduce academic programs. Okay, because in order to have a very useful and fruitful space biology research, training of the next generation biologists or next generation space biologists, we can call it. Space biologists are not 100% biologists. Okay, they need to have an element, or they need to have a component of engineering aspect as well. Then only we can perform biology in space. So along with that, establishment of labs infrastructure is important, and outreach, public interface. So these are all actually part of the vision document. I just wanted to tell you that the country has taken this particular aspect very seriously. Okay, so the vision documents will be available for the public in the coming days. Okay, before that, I'm just telling these all things are already planned. So the space biology products, how to take them into societal application. This is one important, very important aspect, because for any space experiment or any space endeavor, we spend a lot of money. So how to bring back the benefits back to Earth? Okay, this is one among the important agenda of Indian space program as well. Benefit of society, brings the space research back to societal benefit. Okay, so the fourth step, definitely everything, whatever we are doing, it has to undergo review, and revision has to be there, and corrections, midterm corrections has to be there. So what we are ultimately looking forward is to equip ourselves for longer duration missions. Okay? Fortunately, we are having so many research data available. Okay, knowledge domain is so big, but at the same time, developing ourselves, developing our own capability within the country also becomes critical. Okay, so recently, China is setting up its own space station. Okay, our country announced its setting up of its space station by 2030. So that is not a small deal. Okay, when you have to accomplish that particular thing, the whole nation has to have the united spirit. Okay, so no separation between scientists, no separation engineers. Okay, we have to be a collective group to attack the problem. Okay, so that the country can have its own indigenous capabilities. So the decadal plans have been made. So most important is to sustain the program. Our human space flight will not stop with one Gaganyaan. So even if now the opportunity is not there, it is going to be there for you in the future. Okay, so then life into space. Here we are talking about the key component. Now when we are introducing human being as the key component, without saying it, the human being becomes the most critical component in human space missions, right? So as a result of which, human engineering is something which is an evolving domain. Okay, so for those who are not familiar with, we are having one institute in Bangalore. We call it as Institute of Aerospace Medicine. So there is one huge group working on human engineering, where the aerospace engineers work closely in collaboration with medical professionals. Okay, So the different forces when the body is, when the acceleration vectors are introduced in the body during the launch and all, it is very, very clearly demonstrated over here. For example, whenever there is the one particular force being applied, the body tries to move in the opposite direction, right? So for example, the body sensation which is associated with the acceleration vector along gx, gy, and gz axis is put over here. So when it is gx given, then usually we get a force in the you get pressurized towards the seat. Okay, so you get pressed in the back seat. So if this is the direction of the vector, this is going to be the force with which you are being pushed. So the amount of force with you can withstand. Okay, so these are all associated with the launch vehicle capability plus the design of this our mounting module and all. Okay, so there are different. So the common conditions, these are all familiar to all of us. The common conditions during space flight include the loss of appetite, then the motion sickness, most of them face fatigue, insomnia definitely will be there. Dehydration is a very important aspect. Then dermatitis, then back pain. Those all aspects, from person to person, it actually varies. Okay. So most important is to understand that with respect to the physiological alterations also happen. With respect to the physiological alterations during space flight, it is having a direct correlation with the duration of the flight. Okay, as a result of which, some of the characterizations or some of the alterations are said to be short-term physiological, and some others are called long-term. Okay, so if you look into here, this shift of this fluid, central nervous system fluid shift, and headaches, those back pain, anxiety, these all aspects are actually coming as short term. So once you come back and you have ample care for a few days, these things will be actually getting eliminated from the body. Whereas things like the bond density loss, 1.2 or maybe around 1.1 to 1.2 percentage bond density loss is seen when you are spending time maybe beyond a month or so in the space. So the nephrolithiasis, this is what we call as kidney stone. So we are having this kidney stone formulation here in space flight. So this is another aspect I just wanted to highlight here. So, and apart from that, so many radiation-induced changes are also happening as a result of long-term durations. Okay, again, the whole set of physiological changes are listed in this particular journal article. You are requested please to go through if you are interested in. Okay, so now the question comes, after these many space flights, for example, over 260 people have now spent much of their time, so much of time in ISS. Over 560 people have taken space flights already, space travels already. So we have a lot of information available on what all things will happen with respect to human body, right? So what is the point in researching further? That is one point, because if the country is starting research, why don't you take data from other places and then just proceed with your flight? The problem is that it's mentioned over here, because the individual sensitive to the so-called space flight stressors, it can be gravity levels, it can be the stress levels of the flight, it can be the radiation levels, whatever. So the stresses which modulate the biological responses, they have a large dependence on the genetic, demographic, as well as the lifestyle variabilities. Okay, so from one country to another, there are several variations in these aspects. So with respect to Indian space programs, studies are relevant, or studies should be undertaken using human subjects selected from Indian community. Okay, so that is important. And currently, the research is actually highly developed in this particular area, where the multi-omics approach, it is actually the protein studies to the cellular level. Then you are having anything, chromosome studies to the molecular level. So the omics refers to the deeper learning. Okay, so the multi-omics approach is currently being utilized to monitor astronauts, and these data has been sufficiently documented by the NASA researchers, and some university collaborations are also there. and you can actually go into the details of this particular research in this cell reports article. So this is another important aspect I just wanted to tell you about. Okay. So here, the challenges, the life into space. So what are the challenges of space flight? So we already demonstrated, or we already discussed some of them, because the extreme challenges are brought in when we are taking life into space flight. Okay. So the the 5 important parameters that are marked as NASA as hazards of space flight are distance. So we are traveling long distances, and when it comes to deep space missions and all, we are traveling unbelievably long distances. We are trying to travel. Then the confinement. So when we are, for example, in the case of Gaganyaan and all, we are actually confining these astronauts for 5 to 7 days. Okay. So this confinement is going to give you a sort of, now we all experience that confinement. We are sitting at home, or we were sitting in the lockdown period and all. So the confinement brings in some of, even physiological, psychological stress to large levels we are experiencing. Other than that, the closed environment, the hostile environment, some huge noises will be there in some cases when some instruments are being operated. But those things all are refined these days, and the radiation hazards are there. Apart from that, gravity, again radiation. So these are the space risks and health consequences that are severely documented. Okay, so these things are very important because the fitness, these infections, the muscle atrophy, even cancer. So these are all documented by the combination of one or more of these components. Okay. So the sleep, for example, the sleep disruption can be an offshoot from the large distances, the confinement, up to this gravity. Okay. So these many things are actually we are challenging ourselves when we are endeavoring into this human in space mission. Okay. So when we are taken away from food, away from Earth, there is no air, no food, no water apart from what we carry. So we have to become a self-sustaining system, and we have to protect ourselves from the high levels of radiation levels once we cross this Van Allen belts with respect to the deep space missions. Okay. So the space risk, I just again noted it down, because with respect to these many features, there have been a lot of tremendous amount of experimentation. Okay, so experiments were conducted and a lot of analysis also were carried out. So it included the environment monitoring, the space environment monitoring, then the temporal astronaut monitoring. They are confined with respect to the time, with respect to the nutrition, with respect to the exercise, whatever, even the drugs they take. Okay, and most of the things were actually carried out or duplicated using ground simulations as well as the flight tests. So this is something very important, comparing data with the Earth-based experiments. So into the details of even genetic, cellular, tissue, and vascular, this are variations which are happening with respect to each organism was actually studied. Okay, and from there now various models are also available. Again, I am telling, these models are actually available for not Indian subjects, for other people who have traveled. So we have to develop these many things for our own subjects. Okay, so here now, again, this mission, risk level with respect to, this is a chart which shows the gradation of risk levels. Okay, low, medium, high. Again, I have given this particular web page. Okay, so here no, in the planned human missions, this is an article, published article. Gaganyaan is also coming in 2022. Okay. So the health risk with respect to Indian subjects will get recorded into this omics data or in the biological data in the coming days. Okay. So different parameters. I'm not reading each one because it will consume much of a time. We'll move on to more interesting aspects. Okay. So the announcement is there that we have a lot of challenges there. So in India, the emerging research domains, 2 of them I'm listing here. It's a huge domain, and in fact, when I call space biology, it can have its own limitations to certain areas. But when it comes to bioastronautics, something that which covers the whole spectrum of activities when it comes to the human subject as a space traveler. Okay, so as I mentioned earlier, this is the space biology vision for the country. Okay, so from simple biological systems at cellular and molecular level, including organisms or specimens like microbes, plants, and animal models, we are going to equip ourselves for the development of subsystems for bioregenerative life support and long-time survival strategies. Okay, so if you consider a very rough timeline, maybe it's a very optimistic timeline because in 1 to 3 years we have to complete much of biological system level studies. Then 3 to 7 years development biology, space biology is going to happen. Okay, so the experiments here, both the human in loop and automated, these are two important aspects of space biology, because you can plan for experiments which are having human beings in loop. When astronaut is having, astronaut's presence or the space traveler's presence means the human in loop experiment. Or if we are like developmental flights and all, we have to plan for automated experiments. Okay, so about 10 years we are expecting to have our own bioregenerative life support system. It's a closed loop system. Okay, whatever waste is being generated, it will be recycled. The whole resources will be actually put up in a particular loop, and we will be continuously using the resources. Okay, so the research and development in the area, this is actually calling for technologies. Okay, so there's a huge drive, the huge call for the development of technologies that allow Indian subjects to travel safely and productively in space, because most of the other countries, they have developed quite a lot number of things. Okay, but at the same time, although we are starting now with our potential, definitely we will be in one among the prominent, okay, or the promising component in space biology or bioastronautic research in the coming days. Okay, so for engineers out there, what I wanted to emphasize in this particular slide is, with this vision and all, we plan for numerous number of experiments, be it human in loop or automated. But in my understanding, what is becoming critical, for example, in our experiments, I will be talking about that slightly later. In our experiments, what I felt is critical is to build the hardware for the experiments. Okay? So the hardware has to take into consideration the biology aspect. Life cannot be compromised. So how good I can take life to space and bring it back after the life can perform its function productively there in space. So that is the challenge that is
Looks like there is a minor disruption. Yeah, madam. Yeah, we can start. I think there was a disruption.
Am I audible?
Yes, yes.
Yeah, sorry, I have a power failure here, so I have to connect it back. That's a problem. I'm extremely sorry for that. So my screen is back now.
Yes, ma'am.
Yes, madam.
Okay, fine. Yeah. So we continue with the domain, emerging domains, this space biology, sorry. Yeah. So the
Thank you.
criticality of hardware, I have already mentioned. Yeah. So these are the important domains that I wanted to talk to you today. This is about bioastronautics. This term is not much familiar to our Indian community. It is nothing other than a combination or the cocktail of all the disciplines, whatever is available. For example, biology, engineering, medical areas, as well as space sciences. If you try to make it into a concoction so as to address this human in space problems, then we call it as bioastronautics. Okay, so especially the usage of engineering as well as technology to facilitate healthy human inhabitations of space. That is what we mean by bioastronautics. So what the medical risks in space flight, I have already mentioned in an earlier slide. I have just put it in here so as to have a better grasp for people who are interested in. So here our challenge is to have to protect the astronaut during and following space flights, especially long duration flights, and to provide them with the resources, the life-saving resources like air should be there, water should be there, food and medicine. Again, during when we are performing all these things, definitely the challenges of the gravitational biology, because the deprival of these gravity conditions, whatever situations we encounter, we have to actually face those situations also. Okay, so here again, this was one among the articles which was written by the current director of Human Space Flight Center, Dr. Unikrishnan Nair, about the bioastronautics and the plans for India. Okay, so this article you can refer to if you are interested. The other article gives you much about the medical risks in space flights. Okay, yeah. So what are the areas that engineers can look into? Okay, so here I have actually put up some of the areas that IAC has actually proposed, and we have in-house capabilities as of now. Okay, so the whole goal of this particular exercise was to collate the research in space sciences as well as basic science which are happening in our institute to the benefit of the space organization, especially our own space organization, and at large for society. Okay, so these are the areas I have mentioned over here. Bionic science and engineering, you people will be pretty knowing them about bio-inspiration and bio-inspired systems, biorobotics. We also work on multi-stimuli responsive materials for actuation purposes. We call them as smart materials. So it is in fact one among the research areas in my group. Other than that, bioreactor design and process engineering, so tissue culture studies, tissue regeneration, then the bioreactor design and all can happen. Okay, and bioregenerative life support systems, where we will be customizing many life supporting systems, and even the ambience inside a module with the different display systems and all, no, we can actually make. Okay, and other than that, the environmental control of a crew cabin becomes a very critical aspect. So this one wing is actually set up at the Human Space Flight Center in Bangalore. So we are also trying to collaborate with them for development of this environmental control modules, sub-modules. Then astronauts' health monitoring, definitely we require interventions from clinicians. Okay, so as I mentioned, Institute of Aerospace Medicine is having some tie-ups with our institute. So we are proceeding with some of the research in this particular area. Then artificial gravity is something that we need to start now. We are in fact starting with a few small steps we are endeavoring into. And space medicine is one area where currently in the area of drug discovery, my group is started already working, and the molecular docking mechanisms also we are now trying to find out. I mean, really need. So here these are all areas. In fact, if students are looking for internship opportunities within IAC, I would say that these areas are available within the institute for you to start with some small projects. Okay, you can note it down, and in the longer run, IAC has the IAC has put up a big vision so that we set up something called Indian Consortium for Research in Bioastronautics, and IAC will become the nodal center supporting all the institutes with the basic requirements for the space technology or space science related research in this space biology, especially in the area of space biology and human space missions. This is one of our aims, long-term goals, we can call. Okay, so when we come to bioastronautics, the global picture is actually a huge picture. Even though the term is not much familiar in India, this is a global picture, and these are the links where you can actually find some of the research or internship opportunities in this particular area. Okay, so the Texas Aerospace Engineering, Bioastronautics and Human Performance Division, I mean, it's a huge institute. University of Colorado Boulder, we used to have one MOU with that institute earlier. Then Harvard MIT program in health science. They are all having dedicated programs in bioastronautics. Okay, so these are the areas, as I have mentioned a few of them in my previous slide. Other than that, ergonomics becomes very important. Okay, how we interact with our surroundings. Then man-machine interactions. This is one area we can start thinking about. Then we are having space economics. This I mean different. Not only science and scientists and engineers, economic. I mean the whole country can contribute into such programs which are hugely multidisciplinary in nature. So this NCBRI, this site also give you pretty much information about even PhD programs. Okay, most of these institutes are offering PhD programs also, along with the internship opportunities or master programs. You can please refer to those sites for opportunities. Okay, I will talk about one more important area where the domain is actually called space synthetic biology. This can be considered as a subset of the bioastronautics, what I was just talking about. Okay, so this is having a huge reliance or huge emphasis on biotechnology. Okay, so typically we are actually using this biotechnological systems for engineering biological systems for space exploration, for use of industry. For example, some microorganisms, they are very well used in industries as catalysts. So most of the things, they get explored for space and then they get translated into industry and maybe even basic science laboratories. Okay, so when we consider space synthetic biology, you can call it as a hybrid, or it's a mix of aerospace engineering and biotechnology. So the ultimate aim is to have the space metrics like mass, power, volume reductions. And when we bring in biological species, the redundancy become a very attractive factor. So many of the time we can bring these aspects into a cost-effective thing. And the versatility when we are using this biotechnology or the microorganisms or anaerobic or aerobic or whatever, you can use them. Okay. So the microbes are even all the domains, all the three biological domains, bacteria, archaea, and eukaryotes, they are currently being harnessed for space use. So similar thing, there is one program, similar thing going on in National University of Singapore, where I used to have one interaction with one person there. So he is actually an industrialist, but currently they are using these microbes for some industrial use, which they want to try for some of the space applications as well, space biology related research as well. So there are very many challenges, definitely, and along with challenges comes the opportunities. So here, the extraction of these resources using biological means, okay, and the utilization of this limited space resources by cycling them over a period of time is very important. Then definitely the manufacture and construction of products, because whenever we are, for example, when we think about constructing a habitat in other planet or other space, we need to have sort of materials, right? So the manufacturing becomes important, then the construction becomes important, stability becomes another important factor. Okay, so these are all challenges, opportunities in synthetic space synthetic biology. But important thing is that, yeah, this is the full article, full details present in this particular article. So this is one of the artistic depiction of the 6 major grand challenges we can talk about space synthetic biology. And in the next slide, so before moving into the next slide, these are very, very important to long duration missions. So deep space missions cannot survive without the development of space synthetic biology. So in the next slide, I just put the grand challenges in the paper, whatever is available. I have just put them across because the 6 of them include the resource utilization. Okay, so the behavior of these materials in the extreme environments, then the capacity to harness them, the managing of volatiles and minerals, then the feedstock production, then how to proceed with the manufacturing process, and finally how to use the cell-based biomaterials. If you can use materials that are generated by biological bodies for construction and all, it becomes a sort of a closed loop thing, right? So like that, life support is there, manufacturing, this regolith or whatever. So ISRO has actually patented this lunar what is the regolith composition. Okay, we are having our own composition now. It's available for research, I suppose. So this manufacturing becomes important. Then this terraforming becomes important, because the species which are competing for nitrogen and carbon cycles will be used in this particular case. Then other than that, space medicine, this is something very important. Maybe our electronic and telecommunication people or electronic computer science people will be more interested in space cybernetics. Okay, so here no, we are actually incorporating biological species into the control systems. It's a device level biological control system. So the biological species will act as sensors, actuators, as well as controllers. Okay, so here this is a fully biological control system. Okay, everything is managed by a biological system, and the feedback again is sent to the biological system itself. So the biology in loop is available. Different control architecture is available. This is something is going to be futuristic research. Those who are interested can please look into the aspect, because I will not be speaking. Yeah. So some more thing I just maybe I took a lot of time now. So how to start? I mean, I just said many things that you can do this, you can do that, and all. So we will be having, of course, the confusion where to start this research. So as I mentioned earlier, in order to start these particular experiments, it is obviously good to have some microgravity experiments conducted. Okay, so in order to conduct microgravity platforms available, right? Three very commonly available facilities, and the satellites also can be utilized as a fourth platform. So here the microgravity platforms are actually announced in ISRO's call. Please visit ISRO's website for the periodic calls there. So the pre-flight opportunities, we can actually utilize these platforms. Pre-flight in the sense that the real space flight, whichever opportunities are preceding this flight opportunity are said to be flight opportunity. They can be very well used for demonstration experiments in both science experiments as well as technology experiments. You can use them for characterizing of your setup. You can use for refinement of your experiments. You can use for testing of your prototype which are developed. You can use them for certain calibrations of some equipments that you have made, or even it can be used as a test bed for the concept, testing a new concept, or the existing microgravity. Again, I want to emphasize here, the hardware to conduct these experiments are going to be critical. Okay, so the scientific balloons, then we are having the PS4 platforms. This is a PSLV thing, and on the top we will be having the platform where you can conduct experiments. Then of course sounding rockets are available. Okay, so within ISRO these announcements are periodically made. So this is example of, this is the facility for scientific ballooning. So we are having a TIFR facility, balloon facility in Hyderabad. If you go to the website, you will be having all the details of the balloon launch facilities available. So scientific ballooning is one among the pre-flight experiments that you can conduct. Only thing is that the altitudes are actually limited to, say, slightly above the stratosphere, because it is 51 kilometer high altitude balloons come up to 51 kilometers, whereas we are talking about altitudes above 100 or maybe above 400 kilometers, right? So for some of the experiments, it is good indeed to start. The scientific ballooning can be tested. Can go to TIFR balloon facility and just details. Then our Tumba Equatorial Rocket Launching Station is one among the few sounding rocket launching facilities in the world. So the payload capabilities, the altitude, the launch pad, and all the details are actually summarized in this particular slide over here. So here, different mounting decks are available, and avionic systems and scientific instruments are can be very well tested using this particular facility. Currently, ISRO is doing some of the experiments like that also. So this is the second platform which are available to conduct microgravity experiments. The third one that I wanted to highlight here is a very important platform which we call as the fourth stage of PSLV. We call it as PS4 orbital platform, and it can be used for microgravity experiments, biological payloads, science experiments, technology demonstration. You see, so many space is available. Okay, and the capabilities for this particular platform comes in the form of, it is a multiple payload platform. Up to 6 months you can get data. The power is available. So with respect to your payload, the power things you have to confirm it with ISRO. Attitude control, 3-axis attitude control is available. Data storage and communication, all these facilities are available. Okay. And it happened one of the successful payloads, which are advanced retarding potential analyzer for atmospheric studies. Okay, so we already have some experience with taking such payloads. That was a non-biology payload. Currently we are talking about the space laboratory. India's own space laboratory by 2030 is already announced. So not only Indian context, international linkages also will become critical. So currently IISc is looking into expanding. So having said all these things, why should we focus on space biosciences? Okay, so what is motivating us? Definitely the spin-offs from these research, whatever went before, it is actually those accomplishments in space, the impacts that they have made on Earth actually propels us towards more such of research in space biosciences. Just to give an example, more than 1,500, it is actually now the list must have been updated. It is near about 1,600 products have been spin-offs from space technologies, several of them in medicine. Medicine and all these things means common people are utilizing them, right? For example, like artificial neuro arm, telemedicine is an offshoot, then LAVs, LVAs and all, left ventricular assist device and all, they're all offshoot from space biology research. Okay? And with respect to ISRO's achievements, prosthetic food, different sensors, biological sensors are all offshoot from these experiments. And whatever you see here, this GIS or high resolution camera, or these forms on which we sleep, or this small vacuum cleaner with this size holding, all these are actually spin-offs from the so-called the space research, and most of them were towards this human in space program. Okay, so at IISc, what currently we are doing, in the introduction, Professor Manoj was telling, currently we are in the process of developing an internal payload design development for the first development flight of Gaganyaan. So this is the project on which we are working, and this is our research team. I'm hugely helped by my collaborator, Dr. Ravi Kumar, who is an expert in Drosophila genetics, and he has been with NASA for so many years. And this project is actually funded by Human Space Flight Center, ISRO, and we are also supplying the hardware which is developed for this purpose to other institutes like TIFR Mumbai on an MOU basis. Okay, so what we thought about is that the space biology or space research using animal models. So it has long been documented that models can or are pretty good in giving information for informed decisions for astronauts' healthcare. Okay, so we thought about taking this fruit flies. The scientific name is Drosophila. They are from eukarya domain. For geneticists, these are called golden bugs, and you see these many people here. They were all happy receiving the Nobel prizes. So the 6 Nobel prizes in physiology and medicine was actually due to research in this particular animal model. Okay, so why this model was chosen? Because of its the highly conserved biology, basic biology being highly conserved, and the disease gene similarity existing between humans and Drosophila, 77%. It's good enough to have basic studies happening or get starting basic studies. And definitely there are many other attributes which tell this Drosophila to be very good space flight travelers. Okay, for example, this is documented by NASA, tiny flights making big biology happen in space. NASA has over 2 to 3 labs already set up dedicated for Drosophila research. In IST, we started with a small Drosophila research facility. So we have our own space biology lab now. And this is a document, I mean, this is a quote from ESA. Many things that happen to flies in space also happen to humans in the long term. So this also motivated us to choose this fruit flies in space. Okay. So when it comes to the sending them to space, you cannot simply send, or you cannot simply perform the experiment as we conduct on Earth. So we have to have our own special hardware to be developed. So this is something NASA already has developed. Okay. So with respect to our functional requirement, the launch vibrational load is different from what NASA is performing, and the biological system in numbers as well as in the diet, everything are different. So we are trying to make a biocompatible habitat. The prototype stage we are up to. So we call it as fruit fly habitat for Gagania and FFG, where different assemblies are mentioned over here. There will be, it's a completely autonomous system. So we will be launching it, and once it comes back, we will be analyzing the data from the data analyzer, which is an 100% autonomous system. When it happens to the same experiment, when we want to perform it in human in loop system, then this is the case where can use cassette type of hardware, and the astronauts or the space traveler will be intermittently changing the food for the flight. Otherwise, food, everything will be enclosed in the same compartment and will be sent. So the on-ground optimization of the experiments are going on. I'm not giving any details, further details of this particular research, maybe next time. So for me, it was a transition from Earth-based laboratories to space-based laboratories. So we were already in the development of drug-like molecules, because being a synthetic organic chemist, my experience, my training is in chemistry. So with that, we developed a lot of drug-like systems, and currently those systems are being explored for the anti-nephrolithiatic property using space flight studies. Okay, so that is the summary of the research in that particular area. So how do we conduct space biology at laboratories? We also started some working on gravitational science, or gravitational biology precisely, where we started building microgravity simulating platforms. So this is one example for such a machine, the random positioning machine. So it's a three-dimensional machine that works on a random walk algorithm. Okay, so it's a microcontroller. It's a control device. So here, we actually developed it. It's a part of an MTech project, and we evaluated it with a lot of biological studies, including plant as well as small animal model, Drosophila models. And the advantage is what is different from what is existing already is that the student was able to develop some tiltable mechanism, and we are currently protecting, the design protection is ongoing in this particular, so I'm not giving further details. So different position, inclination position, and the time with which we can achieve microgravity, we got very promising results. Okay, so this is something that a student developed. So again, the point is that this is a master's project. So similar internship opportunities also exist in my lab. Sorry. Yeah, so this is how it's rotating. If you can see, assembly we made it, and it can rotate in both the horizontal as well as inclined position. So now it has become a more perfected thing. Okay, so this is the girl made, Sujana made it in her master's final year project. Okay, so we conducted several experiments, and very good results we are getting. Okay, maybe in the step writing. Okay, so to sum up, in the next few years, I'm considering to include the artificial intelligence, which is very, very important when it comes to the space biology research. And we will continue with our research on personalized medicine. And again, I would like to have collaborations for having this IoT in this microgravity simulating platforms. This is another very, very promising. Maybe we will have discussions further with whoever is interested. Okay, so whatever I said is actually a very broad picture of space life sciences. A lot of opportunities, lot of challenges are hidden. Okay, with respect to Indian subjects. So here, when it comes to, it's a huge. I mean, it's a what to say, time taking and your perseverance checking domain. Okay, so you start with the survival kit, your know-how, you have the design flightware, you have several plans. Okay, so finally to the launch pad. This is the Kennedy Space Center. Anyhow, we will be talking about our Sriharikota launch pad. So this is an old a cartoon which I have taken from this particular reference. So what I wanted to tell is that the life cycle of a typical bioscience flight experiment is actually pretty huge. I mean, it's a big duration. Almost 5 to 6 years it will take to reach the launch pad. Then post-flight analysis also is there. Okay, so throughout this time, the cooperation between the biologist as well as the engineer, the person who is helping with the hardware, it has to be flawless. With every input the biologist is giving back, the engineer should be able to or should be willing to provide the verified model. Okay, so what all factors are important for life has to be equally appreciated, not only by biologists but also by engineers. Okay, so with that, what we are doing, what in India, what we are trying to do is that we are trying to have huge learning platforms. This was one among the first symposium on space flight and exploration, which happened in Bangalore in 2020 Jan. After that, everything changed. The whole world changed. Okay, I was fortunate enough to participate, and I could meet all the six astronauts were present. Okay, this is Oleg and Orlov. Later also I listened to so many lectures from him. And not only this whatever awareness, we need to have these many components also in order to survive the space biology or in fact human space missions. Okay, so the vision should be expanded to an international vision. We should have a national spirit, because every time we think about our country, that becomes that should bring a lot of pride. Okay, then you should be steadfast, and you should have a very goodwill should be there, and your optimism should not be tampered at any cost. So that's very important. Otherwise, people will tell many things, and if you get distracted, it is going to be difficult. Okay, so we have a lot more to learn, and way long to go. That is very important. So we learn from these many people. Okay, so this is my current collaborator, Dr. Ravi Kumar. So Dr. Sharmila, she is from NASA Ames, the food flight lab director. Okay, so Dr. Anupam, Indian aerospace medicine person, and this person, I hope you all know, our only one Indian citizen astronaut. Okay, Rakesh Sharma. Fortunate enough to have some discussions on the project with him. So this is our Vyomitra. So for our teachers sitting over there, the bringing space biosciences to students of all levels, that is an important thing that we have to start now. And in IST, we have already started a program. This related to space biology, but not 100% astronomy. We are now opening up some of the programs in the space biology domains as well, with expertise shared from other institutes that will be coming up. Okay, so as a ending note, the scientists as well as engineers should consider increasingly the space flight as a tool, and the findings of the space research have to be integrated into the traditional disciplines. So myself being a chemist, if I think only I can do chemistry, then difficult to sustain other programs. But if we are trying to integrate findings of other areas into our discipline, definitely it is a great opportunity. And yeah, so my sincere gratitude to IEEE, it is IEEE EMB Kerala chapter. Definitely my institute has supported me throughout, and ISRO has funded many of my projects. And finally, all my students and collaborators for presenting, for giving this opportunity and information for the presentation. And finally, I thank you all. I think I consumed a lot of time. I'm extremely sorry for that. But again, this being one opportunity, I thought of sharing whatever platforms are available for others to take up, okay, research in other areas also. So this is all from me. So for more details, you can go into my webpage. It is listed over here, or you can send me an email. I'll be happy to answer your queries. Okay, yeah. So that is from my side. Professor Manoj, I hope you are there.
Yeah, thank you, madam. Thank you. It was an excellent talk.
Yeah.
Thank you so much for the wonderful session, ma'am. It was indeed a great session, bringing together all aspects of space biology with well-detailed PPTs. I'm sure the participants have no objections to that. It was great listening to you. We have received some queries regarding the session. Ma'am, shall I read it out for
Yeah,
you?
please. Yeah,
Others
please go ahead.
Okay. Others may kindly post your queries if you have any. Ma'am, so the first question is, how can we register ourselves for the newsletter?
Yeah, you just go to their website there. That International Space Station R&D one website is there. Okay, if you go through my lecture thing, no, that registration link, when you go through that also you can register. It's a direct registration, nothing much of formality. Okay, because it is a public interface for them. There's no hard and fast rules there. Direct from the website you can register.
The next question is, when spacecraft and spacesuit material chosen, is the amount of radiation penetration they allow a factor which influences the choice? If not, what other measures can be taken to optimize the radiation safety of the people inside?
Jayashree, can you read it one more time? Comparing what all things? Hello?
What other measures can be taken to optimize the radiation safety of the people inside?
Yeah, so the radiation tolerance by human beings, we have specific values, okay, and that is the reason why different and all a single material is not able to give you that particular measure. Okay, so what we typically do is we do experiments with different layers of material. For example, if you are having a material which is high in hydrogen content, it is already known that such materials have a high level of radiation cutting, which is possible. Okay, so by trial and error method only we can go about. And when it happens that a particular person's sensitiveness towards certain radiation level, that also should be taken care. So it is actually the person centric, so more sort of a personalized thing when it happens for the 100% design of such spacesuits. And if I'm not wrong, if the question is asked from IST person, we do have one textbook dedicated, okay, where the spacesuit design itself with all the aspects we are talking about is available. Okay, if you are from outside, you just send me a mail. Maybe I can just give you the reference so that no, the whole it's a huge process of having the radiation shielding, especially using space shields and face masks. So different parameters are coming into play. Yeah.
Ma'am, the last question is, in 2007, SRE-1 proved to be a successful mission. Could we have used the capsule to act as a lab for microgravity experiments?
In fact, SRE was used because even though we now listen to this Gaganyaan announcement, which came in 2018, in fact, ISRO's space biology program started long back by, I think, in the start of 2000, 2004. During this period only, this SRE 2007 and all, no, these experiments were performed, right? But the thing is, many such data are available. I personally know people who are having data, and we had several discussions. And some of the articles are also available. Okay, so this space recovery capsule and care experiments, most of these experiments, whenever possible, biology was explored. Okay, there's no doubt about that. Even our IST, we made one sounding rocket way back, long back the time. Even that sounding rocket can be made again, and we can use them as platforms. One among the microgravity platform that I discussed was the sounding rockets, right? So even IST is now having some balloon capabilities. So microgravity experiments can be done. The precise answer to that question is it was done already. Some of the experiments, okay, but the data I'm not having now. Experiments were done, that is for sure. Yeah.
I believe that's the end of the queries. Thank you, ma'am. It was indeed a huge enlightenment for us. Now, as a token of love and appreciation for the impeccable session you delivered, we'd like to share our gratitude by sharing a virtual memento. Manoj sir, please. Ma'am, kindly accept this, which we consider as a representation of our boundless gratitude.
Sure. Thanks a lot. Looks great. I'm really sorry that I consumed too much of time, I think. Okay. Yeah.
No worries, ma'am. I kindly request all the participants to fill the feedback form shown in the chat box. Now, I invite Dr. Nidavi Panikar, Faculty Advisor of TKMIT SP and member of Exicom, to deliver the vote of thanks. Nita ma'am.
Yes. Good afternoon, ma'am. Good afternoon to all. First of all, let me thank the organizers for giving me an opportunity to thank Professor KG Srija Lakshmi, Associate Professor, IAST. And she had covered an overview on the biology in space, challenges and opportunities for engineers. So most of us learned a lot from her presentation. I'm sure that she covered the importance of the optimization in the laboratory and space insight into the earth-based experiments, then covering into the space life science research perspectives and ISS R&D, then finally about our Gaganyaan project of our own India, then also covered the human engineering aspects and also the space risks involved in this bioastrophysics as well as the space synthetic biology. So covering a lot of interdisciplinary domains so that all of us can find some problem from that. I'm sure that it is a privilege for me to give a lot of thanks to you, ma'am. On behalf of the entire EMBS family, I wish to express my sincere gratitude. Thanks to Dr. Srija Lakshmi. Thank you, ma'am. And also, I wish to thank Dr. Ravindranath, Sumitra Nair, Priscilla Koshi, and all others present, especially Dr. Manoj P.S., Dr. Mr. Baiju N.B., Dr. Jayashree ma'am, Yuvraj sir, and we are lucky that we have fortunate enough to have almost 85 participants for the program. And I thank all of them for showing their interest in the program. So once again, thank you all who assembled here. Thank you.
Thank you, ma'am. Thus, we have arrived at the end of today's session. We are grateful for having you all today and for your cooperation. I'm pretty sure this webinar had flash insights to your mind. Thank you, Sri Lakshmi ma'am, for giving us such an informative session. We're very glad to spend an hour with you. Looking forward for your support in the future as well. On behalf of EMPS Kerala Chapter family, thank you once again from the bottom of our hearts. This is Amina signing off. The meeting is officially closed.
Thank you so much. So, Professor Manoj, can I leave now?
Yeah, yes.
Thank you, ma'am. Thank you, ma'am.
Thank you all.
Thank you. Thank you, Dr. Yeah. Thank you so much.
Amina, thank you. Thank you. Manoj sir. Okay.